Now let us study the maxima and minima of a function. Previously we have seen how to check whether a function is increasing or decreasing based on the derivative. Now here we want to know what is the maximum value or minimum value attained by a function in some given interval. So that is nothing but a continuation of the idea of increasing and decreasing functions. Now here if we consider those points, that is the point where the function attains the maximum value as well as the minimum value. So these points are marked here on the graph, right? We observe that if we draw a tangent at the point of maximum, that tangent will be definitely horizontal, and similarly if we draw the tangent at the point of minimum, there also the tangent will be horizontal. So we see that in both of the cases, since tangent is horizontal, its slope, which is nothing but the derivative, has to be 0, isn't it? So whether it's a point of maximum or the point of minimum, the derivative will be 0 for both of the cases. So how do we differentiate between whether that's a point of maximum or a point of minimum, right? So to do that we have two tests which we call as first derivative test and second derivative test, right? So let us go to these particular tests and see how we can differentiate between the point of maximum and minimum. So just to repeat, to begin with we must have the first condition as the derivative is equal to 0. So that gives us these two important points, right? These are the kind of important junctions where we have the slope of tangent as 0. Now let's go ahead and study the first derivative test. Now in that what do we have is, let's consider the case of maxima first. That is, suppose we have a point of maximum as shown here. So this is the point where the function becomes maximum, and we know that if we draw a tangent at that point, its slope will be equal to 0. Now if we consider some point which is little to the left of that particular point, let's call the point of maximum as A. So let's consider some point, say A minus h, where h is a very small number. Alright, so here we consider h is a positive number, but h is very small. Okay. Alright. Similarly, we consider the point which is on the other side of A at the same distance. So that will be A plus h. So here also the distance is h. Now what do we do is, at these 2 points on the curve, we draw the tangents. So here the tangents are drawn. Now we can see that the tangent drawn at the point where we have A minus h, the slope of tangent will be positive because that line is an increasing line, isn't it? So the slope of that line will be positive. Whereas the tangent drawn at point x equal to A plus h, the line is sloping down. So therefore the slope of that tangent will be nothing but negative. So that means if we have some point, say A, where the slope of tangent is 0 and the slope of tangent to little left of that point, that is A minus h, is positive, whereas the slope of tangent to the little right, that is at point A plus h, is negative, then it means that the point A itself must be on the top. That means it must be the point of maximum, isn't it? So therefore that is what is called as the first derivative test, because we use the derivatives to detect whether the point x equal to A is the point of maximum or not. Now similarly we can also develop the condition for the point of minimum. That is, let's consider now the point of minimum. So therefore here is the point. Let's once again denote it in general as say A, and here if you draw the tangent, it is horizontal, right? Now if we consider some point to the left of it, that is a minus h, and some point to the little right of it, that is point say a plus h, and let's draw the tangents at these 2 points. Okay? So to the left and to the right. Now the tangent drawn at point x equal to a is definitely horizontal, so therefore its slope is 0. Now if we consider tangent drawn to the left point, since it is sloping down, so therefore its slope will be negative, correct? And the tangent drawn at the point a plus h, that tangent is going up, so its slope will be positive. So therefore here we have f dash of x greater than 0. So therefore if we see, if the slope of tangent to the left is negative whereas slope of tangent to the right is positive, that means the point which we are considering where slope of tangent is 0 must be the point of minimum, right? So that is a way to detect or differentiate between the point of maximum and minimum using first derivative test. So here we summarize the rule for first derivative test. That is, in first case we say that f of x has local maximum at x equal to a if f dash of a is 0, f dash of a minus h is greater than 0, and f dash of a plus h is less than 0, where h is some small positive number. On the other hand, in second case, f of x has local minimum at x equal to a if f dash of a is still 0, but f dash of a minus h is negative and f dash of a plus h is positive, once again for some small positive number h. Okay, so that is how we use the first derivative test. Now let us see the second derivative test, which is slightly more elegant as compared to the first derivative test because it has less conditions to check. But nonetheless we still use the same idea, that is, let's consider once again 3 points, right? Now if we observe that for the point of maximum, we know that the first derivative has to be 0, correct? Now if we observe what is happening to first derivative as we cross through the point of maximum, right? Initially the first derivative was positive, then it became 0, and then it became negative. So if you see, as we pass through the point of maximum, first derivative is continuously decreasing, right? Have you understood this? Understand once again. First derivative initially was positive, then it becomes 0, and then it goes into negative. So that means first derivative is continuously decreasing as we pass through the point of maximum. Now if certain function is decreasing, then its derivative must be negative, as we have seen in the topic of increasing and decreasing functions. So if first derivative is decreasing, it means that its derivative, which is nothing but the second derivative, this must be negative. So therefore we get this particular condition, that is, second derivative has to be negative and first derivative has to be 0 at that particular point of maximum, isn't it? So these are the two conditions which we check to detect the point of maximum. Now similarly, it won't be difficult to develop the condition for the point of minimum. That is, once again, if we consider the point of minimum at say A, and we consider 2 points in the neighborhood to the left and right. So once again here we have f dash of x, f dash of x, and f dash of x. Now to begin with, no doubt that the first derivative at that particular point must be 0, whether it's maxima or minima. Now let us see what happens to the first derivative as we pass through the point of minimum. Now to the left side, initially the first derivative was negative, then it becomes 0 at the point of minima, and to the right it becomes positive. So the first derivative is continuously increasing as we pass through the point of minimum, correct? So therefore, if first derivative is increasing, so therefore its derivative, that is nothing but the second derivative, must be a positive number. So therefore the second derivative must be a positive number. So therefore here we once again get another two conditions. These two conditions applied together gives us the point of minimum. Of course, whenever we say that f double dash of x is less than 0, it means we have to actually calculate it at point A. Okay? So whether it is for maxima or minima, we have to calculate second derivative at A and check whether it is positive or negative. Right? So let us go ahead and summarize the conditions for second derivative test. So in case 1, we say that f of x has local maximum at x equal to a if f dash of a is 0 and f double dash of a is negative. Similarly, in second case, f of x has local minimum at x equal to a if f dash of a is 0 but f double dash of a is positive. So just to recap, whether it is maximum or minimum, at both points first derivative must be 0, and for the point of maximum second derivative is negative, whereas for the point of minimum second derivative is positive. Okay. Now based on this we will solve few sums.